2.5 matrix inverse. Division isn't defined for matrices, so we use a matrix inverse to solve that problem. Consider the equation 4x equals 12. Most people would tell you, let's divide both sides by 4, but what are we going to do if we can't divide? If division isn't defined, we're going to have to do something else. So maybe it occurs to you to multiply both sides by 1/4. Turns out that's exactly what we want to do because 1/4 is the multiplicative inverse of 4. We're going to be allowed to do something like that when we couldn't divide. The identity matrix is like the matrix version of 1. It's not equal to 1, but it kind of acts like it. And so you see a couple of examples. I2, I3, I4 all look like that. So what you're seeing is a matrix with 1s along the main diagonal and 0s everywhere else. It wouldn't be hard for you to come up with I5. I5 would be a 5 by 5 matrix with 1s along the diagonals and 0s everywhere else. So in general, I, the identity, is just whatever size we need it for that problem. It might be I2, I3, I4, whatever. Matrices A and B are multiplicative inverses if A times B equals the identity and B times A equals the identity. You have to have both of those things true. A coefficient matrix is just the coefficients taken from a system of equations. How to verify matrices A and B are inverses of each other. You're going to multiply A times B and see if it's the identity. But you can't stop there. If it's not the identity, you can stop. But if it is the identity, you're going to have to also check if the reverse multiplication is also the identity. So that's what we have to show. We have to show that A times B equals the identity and B times A equals the identity. So let's give it a shot. We're going to verify these two matrices are inverses. So I'm going to multiply. 1, 3, 2, 5. And -5, 3, 2, -1. So when we multiply matrices, remember what we do. First, we see if it's even possible. You've got a 2 by 2 times a 2 by 2. And we know that works because the inner dimensions match up, but we also can tell that the answer is going to be a 2 by 2. So you can set up kind of a dummy matrix, a 2 by 2, and that's what your answer is going to look like. After that, you want to multiply rows by columns. So you might do something like these 2 rows times these 2 columns and multiply the first row times the first column. So what you could do, let's see, think about multiplying this row times this column. First row, first column, going to look like that. So you zip up the numbers, that's what I say anyway. Multiply the first ones, 1 times -5 is -5. And multiply the second ones, 3 times 2 is 6. So you're going to have -5 plus 6. We're going to do that for each row times each column. So now I'm going to do the first row times the second column. That's going to be 1 times 3 is 3, and 3 times -1 is -3. I keep going. The second row times the first column. 2 times -5 is -10.
Alan Doherty, if you're in the building, will you please report to the main office? Alan Doherty, thank you.
And 5 times 2 is plus 10. Second row, second column. 2 times 3 is 6. 5 times -1 is -5. Cleaning it up. -5 plus 6 is 1. 3 minus 3 is 0. -10 plus 10 is 0. 6 minus 5 is 1. There's your identity. And that's what I wanted. So I've got that, okay? But now I still have to show the other way. So now I have to multiply it backwards. And the reason you have to do this is because with matrices, AB and BA are not necessarily equal. They may or may not be equal. A lot of times they're not. So if we're going to multiply this, I'll write it out. Write it out in the other order. This is B, -5, 3, 2, -1. And then A is 1, 3, 2, 5. So we're going to multiply. Well, again, we're going to have a 2 by 2. So I'll go ahead and build out my skeleton. And I'm going to multiply that first row times the first column. That's negative 5 plus 6. First row times the second column is going to be negative 15 plus 15. Second row times the first column is going to be 2 minus 2. And second row times the second column is going to be 6 minus 5. So again, we get 1, 0, 0, 1. Great. So now I've got both of those. AB equals I and BA equals I. So now I've got it. You can use the Latin acronym QED. That basically just means we did it. We did what we were supposed to. Or you can actually say A and B are inverses. How to find a multiplicative inverse of matrix A. Step 1, form an augmented matrix AI. So the easiest thing to do here is just take what you've got and let's just add to it. Add the identity onto the back of that matrix. So now I've made a 2 by 4 matrix that's got A on the left side and I on the right side. Step 2 says perform row operations using the Gauss Jordan technique until you have IB. So really all we're doing is trying to do Gauss Jordan. So remember what Gauss Jordan is. Gauss Jordan, we want numbers along that diagonal. Specifically, we're going to want ones and zeros elsewhere. So let's do what we do. I'm going to have to use this 2 to zero out that 1. So in order to do that, I think I could do 2 row 2s minus row 1. That would give me 2 minus 2 is 0. And that's going to do it. All right, so the top row, the circled number doesn't need to change, so I leave it alone. And the bottom row, I'm going to use my rule here. 2 of these is 2 minus this is 0. And 2 of these is negative 4. Oh, you know what? I forgot. I changed this problem. Okay, no big deal. Basically, I don't want that to be a negative. So just change the problem. That's a 2, not a negative 2. Okay, that's a 2, not a negative 2. Otherwise, I get a result that I don't want. So let's just make sure that's a 2, not a negative 2. So then when we use our rule, that's 2 times 2 is 4 minus negative 4. That's going to be 8. Okay, so notice the change. 2 zeros is 0 minus 1. That's negative 1. 2 of these is 2 minus 0 is 2. Okay. Now keep in mind where you're going. You want numbers along that diagonal and zeros elsewhere. So we're going to use this 8 to zero out that negative 4. Okay, negative 4 has to go to 0. Looks like we can do 2 row 1 plus row 2. That would be negative 8 plus 8. That's going to be 0. So 2 row 1s is 4 plus row 2. That's 4. 2 of these is negative 8 plus this is 0. 2 of these is 2 plus this is 1. 2 of these is 0 plus this is 2. Bottom row, I can leave it alone. And now I'm in pretty good shape, except I want these to be 1s. So what I can do now is just divide the top row by 4. Divide by 4, and we'd get 1, 0, 1/4, and 2/4. And then on the bottom, I'm going to divide by 8. I'm going to divide by 8. I get 0 and 1 and negative 1/8 and 2/8. And what you see, remember up here when we wanted IB, that's what we've got. Here's I and here's B. But really, instead of saying B, that's your inverse. The inverse of your matrix here, that's what we're trying to find, is 1/4. 2/4 I'm going to reduce to 1/2. Negative 1/8. And 2/8 I'm going to reduce to 1/4. Okay, now, that's how you do it by hand. If you think about it, though, we've got a lot of technology, and we could do this. We could do this with a calculator. So let's see what that looks like. Okay, so if you go to Math Sites, go to my website, go to Math Sites, and what we did was a Gauss Jordan. So if you find the one that says Gauss Jordan, we should be able to just type in the numbers and go. That was a 2x4 matrix, remember? So let's see, where was it? Here. Okay, 2, -4, 1, 0. 2, -4, 1, 0. And then the bottom row was 1, 2. Remember, I changed it to a 2. 1, 2, 0, 1. So if you do a Gauss Jordan, it's going to give you exactly what you want. Okay, this website is amazing, and it does a great job of the Gauss Jordan process. And you can see right here, there's your inverse right there, 1/4, 1/2, -1/8, 1/4. So pretty cool.